Okay, the nice thing about adding and subtracting fractions is if they have common denominators, you just have to add the numerators. All right, so everybody take a look at number one. Why is this one simple?
Because the denominators are common.
Yeah, so we already have a common denominator. All right, so because they have a common denominator, then you can just add the numerators. So the answer is just what?
5/7.
Yep, that's it. 5/7x. That's how easy, simple. All right. Now, let's take a look now at number 3. Are they almost common denominators? Right, they are almost common denominators because x minus 9 is almost the same as 9 minus x. All right, who remembers what? Yeah, that's right. You have to put a -1. So watch what I'm doing. All right, I'm going to do the whole thing right now, but then you can say, well, that's just kind of silly, all that work. All right, just know this. All right, technically what I'm doing is I'm factoring out a negative. If I factor out a negative, or I should say factor out a -1, right? If I were to factor out a -1, that would make this a -9 and a positive x. So then you could rewrite that as -1x minus 9. All right, so that's the math behind why you do that. All right. But if these are the same, except for the order, x minus 9 and 9 minus x, all you have to do is change the 2x to a what? -2x. And then you can rewrite it instead of x minus 9, you can write it, or instead of 9 minus x, you can write it as what? X minus 9. Now, do they have a common denominator? Yes. All right, so now we just say, what's 14x minus 2x?
16x. No, 12x.
12x over x minus 9. Now, can I cross out the x's?
No.
Definitely not. Things bounded by addition and subtraction, you cannot cross out. Things bounded by addition and subtraction, you cannot cancel out. All right, so that is your answer. Now, as we go down the page, it gets harder. So if you don't speak up, all right, it's not getting easier. All right, any problems with number 3? All right, here we go. Let's take a look at number 5. All right, do we have a common denominator? No. So we have to make a common denominator. So what am I going to do? Okay, so now someone asked me that and I thought that was a pretty good answer. However, all right, if you were to take 1/4 plus 1/2, do you square the 1/2 to get the common denominator? No. The reason why you don't do that is because 1/2 does not equal 1/4. All right, so you're never squaring. All right, you're never squaring. All right, you're multiplying by something. All right, in order to get a common denominator, you have to multiply by something. All right, now, again, I'm not real sure what the difficulty is here, but what am I multiplying the denominator by in the second fraction to make it x to the 4th? Well, I'm not multiplying it by 2, but I'm multiplying it by x squared. I understand what you meant. All right, you're multiplying by x squared. Now, if I multiply the bottom by x squared, I must do what? You have to multiply the top by x squared. All right.
Is it x squared because if you do 2, it would be 2x squared?
Right. So the reason why now, because if I multiply x squared times x squared, I get what? X to the 4th. And then you've achieved your objective because now the denominator is the same. So I'm going to rewrite this just to make sure you're with me. So it's 6 over x to the 4th plus 2x squared over x to the 4th. All right, again, just to make sure, 2 times x squared is the 2x squared. Do you have any questions with that? Now do we have the same denominator? So now we just add them. So if I add them, what do I end up with?
8x squared.
No. What do I get when I add the two fractions? Well, what's the denominator, obviously? X to the fourth. Now, come on, guys. You're telling me you're having trouble adding 6 and 2x squared together. Yeah, can you add those two things together? No, they're different. All right, they're different. So if you want to put 6 plus 2x squared, that's perfectly fine. But generally, we put the exponents, all right, in descending order. So that is your answer, 2x squared plus 6 over x to the fourth. I don't think that's that difficult. Anybody have any questions or concerns with that? Anybody? All right, here we go. So now let's take a look at number 7. All right. So for this particular problem, all right, now I'm trying to make a common, thank you. I'm trying to make a common denominator. All right. So I want everyone to be able to tell me this. We don't have to go so slow. Make one giant fraction bar. And someone tell me what the common denominator is.
20x.
20x, 20 is a possible common denominator, but is it the least common denominator?
That's 6.
No.
10.
All right. 10. All right. I like 10. All right. So, for example, I always ask kids, if you were adding 1/5 minus 1/10, all right, what could I do? What's the common denominator? 10. So it's the same. This right here is 5. This right here is 10. So the common denominator with the number is what? 10. Now, the rule for the exponent is you just take the largest number for the exponent. So in the first one, it's x to the what power? X to the first. And on the second one, it's x to the, so the common denominator is 10 what? 10x to the third. That is correct. All right. Now, basically from there, all right, what we're doing is we're saying from the first fraction, I need the denominator to be 10x cubed. So what do I have to multiply the second fraction by? Come on, guys. 2 what? I need to multiply by 2x squared. The reason why I need to multiply by 2x squared is because what's 2 times 5?
10.
And what's x squared times x? That's all we're doing. So now I'm going to come over here and I'm going to put 2x squared. All right. So the first numerator will be what? Come on.
4 plus 2x squared.
What do I do with these two? Thank you. It's 8x squared because you're multiplying. Remember, you're multiplying these two things together. You're multiplying. Why am I multiplying? I'm multiplying because I'm trying to get a common denominator. So 2x squared times 4 is 8x squared. Tell me.
I thought you said that you couldn't like have them together because the 4 doesn't have like anything.
No, you're allowed to multiply things together. You're not allowed to add things together. Right? Look, if I was to say 4 plus x squared, we don't get anything but 4 plus x squared, right? But you're allowed to multiply things together. All right, now, do I have to change the denominator on the second fraction? No. So it's just minus what? Minus 2. All right, which brings me to anytime you're looking at fractions, you always want to check to see if you can reduce.
Yeah, you can.
By what?
Uh,
Thank you. She's right, by 2. The reason why you can divide by 2 is because the 8, the 2, and the 10 are all divisible by what number? 2. So you just divide by 2. So 8 divided by 2 is what? So we get 4x squared. 2 divided by 2, 1, 10 divided by 2.
5.
That's exactly the right answer. Go ahead.
But that means that we couldn't like reduce this altogether by addition or subtraction.
Yes, I did say that. However, I also said unless all the terms can be reduced by the same amount. And let me give you an example, because again, I'm with you on the rules. All right. Very confusing. So look up on the board. So see what I'm showing you. 4 plus 6 divided by 4. I can't just cross out the 4s. Right? But I can say each term is divisible by 2. So I can say that that's the same as 2 plus 3 over 2. You with me on that? And that's true because I could just say 4 plus 6 is 10 over 4 reduces to 5 over 2, which is what that is, 5 over 2. You with me now, right? So the only time you can reduce is if all the terms that are with the addition and subtraction can be reduced by the same number. All right. So I'm happy with that for number 7. All right. Now for number 9. 7 is really 7 over what? 1. So if you want, make yourself a note, 7 over 1 plus 2 over x minus 2. Now, the thing I want you to realize is that x minus 2 is itself a quantity, not individual terms. X minus 2 is itself a quantity. So what is the common denominator? The common denominator is x minus 2. So everybody's going to write down the giant fraction bar. Now, technically, could we say the common denominator is 1 parentheses x minus 2? Yeah, it's the same thing. All right. So now the first fraction. All right. For the first fraction, what am I multiplying the first fraction by? I'm multiplying by x minus 2. All right. And the reason why I'm doing that is because now the denominator is what? X minus 2. All right. So showing all of my work, I'm going to go ahead and just put 7 parentheses x minus 2. And then plus, am I multiplying the second fraction by anything? Come on, pay attention. Am I multiplying the second fraction by anything? No, you could say 1. All right. But there you have it. That's how simple it is. You're just getting common denominators.
So you don't do like 7x minus 1.
Well, we're there. Yes. Now we're going to distribute. All right. So we have to simplify the numerator now. All right. So she said distribute the 7. 7x minus 14 plus 2 over x minus 2. Now you're allowed to skip steps in here for some of you guys, like I already knew, to distribute the 7. That's what I want you to do. I'm just writing out all the work to make sure you're good. Now you combine terms. So I end up with what? 7x minus 12 over x minus 2. Now, can I reduce the 12 and the 2? Definitely not. Definitely not. Can I reduce the x's?
No.
Definitely not.
That's a big
All right.
no.
Here we go.
Anything bounded by this.
So now for question number 11, this is what I was trying to talk about. The x minus 4 is itself a quantity, and x minus 8 itself is a quantity. All right. So what is the common denominator? X minus 4 and
X minus 8.
x minus 8. Those, or that is the common denominator. So what do I have to multiply the first fraction by? So again, you're looking here, guys. Now here's starting to get a little bit more complicated. I'm looking here, and this is what I have. So what's missing? Say it again. Yeah, the x minus 8 is missing. So I'm multiplying the first fraction by x minus 8. What am I multiplying the second fraction by? By x minus 4. So you're going to put a minus 7, and an x minus 4. So essentially, I just did this by x minus 4, x minus 4, and on this one, I did x minus 8. And that's how I got the common denominator to be x minus 4 times x minus 8. What?
I'm confused why you said the x minus 8 is like missing.
Okay, so this right here, I need you to agree, is the common denominator. Do you agree this is the common denominator, right? So now I'm going to go back here. All right, in order to add the fractions, I have to have a common denominator. So this fraction needs to have a x minus 4 and x minus 8 as the denominator. It's missing which one? That's right. That's why I had to multiply this by x minus 8. And I had to multiply the denominator by x minus 8. On the second fraction, I'm missing a what? So I had to multiply the second fraction by x minus 4. Right? And now we're just distributing. If I distribute the 3, I get what? 3x minus 24. Now distribute the negative 7. Negative 7x plus 28. Now simplify the top. What's 3 minus 7? 3x minus 7x. Negative 4x. Negative 24 plus 28 plus 4 over x minus 4, x minus 8. Okay, look at 13. Why is this one nice?
Bottom's the same. bottom's
What?
the same.
Oh, the last one, do you not use like the x
Bottom, big
squared?
bottom. Bottom, you can-
No, you don't want to multiply this out because I'm trying to see if anything can reduce. No, this is not being multiplied
Wait, why?
because I'm trying to see if it can, if I multiply it out, I can't see if it reduces.
Well, how do we find it?
Okay, let's do this. If you multiply that out, it's not wrong. So if you want to multiply it out, feel free. All right. Go ahead and multiply it out. I don't mind. All right. The rest of us will not multiply it out. It's just more work.
Who wants to do
All right. Now, for number 13, x minus 3 already has common denominator. So this one is easy. All right. So all we have to do is put x minus 3 on the bottom. However, all right, this is where people make mistakes because of the minus. All right. I want to make sure that you understand this minus is to the whole numerator. So what I would like for you to understand is this subtraction becomes what? Addition. And then the positive 5 becomes a what? Negative 5. And the negative x becomes a what? Positive x. It's like distributing a negative 1. It's like distributing a negative 1. Now, why do we do that? Because if you don't, most people don't understand I'm subtracting 5 and subtracting negative x. All right, that's essentially what you're doing when you put a minus sign there.
Why did you just say that? I'm confused.
I'm subtracting 5 minus x. That's what I'm subtracting.
Mhm.
So if I'm subtracting 5 minus x, that's going to be negative 5 plus x. You with me? All right. So whenever you see minus, I personally think it's easier to just change it to plus and then distribute that negative. And now you're just combining terms. And when I combine these terms, 2x and what? 2x and x becomes what? No, 3x. 3x. 2x plus 1x is 3x. Now you're looking at -7 and -5. -12. All right. Now, I just want to make you aware, because sometimes this can be on standardized tests. There's a GCF in the numerator. What's the GCF in the numerator? 3, thank you. And so then I need a what?
X minus 4.
X minus 4 over what? X minus 3. Can anything cancel? No, that's what I was trying to tell someone earlier. All right, you always want to deal with the factors, not the products, because I can't tell if the products will end up canceling out. All right, and you always have to reduce a fraction. Anybody have any questions with 3 times x minus 4 over x minus 3? What?
Why would you reduce?
What can I reduce?
Well, 3.
The 3 with the what?
Well, and the other 4.
No, the reason why you cannot reduce these, because these two things are held together with subtraction. These two things are held together with subtraction. You cannot reduce things bounded by addition and subtraction unless all the terms can be reduced by the same number. All right, that's right. Now, if there was a 6 here, you could reduce them all by 3. All right, but there is no 6. All right, so now let's go on to number 15. All right, here we go with 15. All right, so now again, all right, you're thinking about 4 and 10. What's common with 4 and 10? Well, no, you're right. A common, not a common factor. We're doing common multiples. All right, so there is a common 20. And I said you take the largest exponent. So it would just be 20 what? 20x. That's it. All right, come on, it's not that hard. 20x. I want the denominator here to be a 20x. So how do I make it a 20x? Multiply it by 5. So if I multiply by 5, I have to multiply the top by 5, which makes that what? 25. Now I multiply the second fraction by what? 2. So multiply the top and bottom by 2. So that's just going to be 25 minus what?
23 over 20.
And so he is correct. 23 over 20x. And again, there's nothing there to reduce. Nothing there to reduce. All right. Any questions? All right, here we go. Lots of problems now on 17. Finally, something that's a little bit more challenging. All right, so make yourself one fraction bar. You're smart enough to do that. Now, I tried to tell you that when there's addition and subtraction involved, that is considered a quantity. This right here is considered a quantity. So what is the common denominator? Someone give it a shot. X plus 5 and what? Times 2x. That is the common denominator. These two things are the common denominators. So because the 2x is by itself, generally we write it as 2x times x plus 5. That is the common denominator. All right, I don't think that's that hard. Now, if I look at the first fraction, everyone should be able to sit there and say, okay, I need to multiply the first fraction by what? By 2x. All right, now how did I know that? Because I need the 2x in the bottom to have the common denominator. Just like on the second fraction, I need to multiply it by what? X plus 5. I need to multiply this by x plus 5. All right, so this one's a little bit more challenging because we have to review some rules. So I'm multiplying 2x by 6x minus, I'm taking x minus 2 and multiplying that by x plus 5. All right, so now this one's hard, bless you. Everyone needs to put a little star by this. Now, in a minute, I'm going to say we need to multiply these two things out. And some of you are going to say, well, a few minutes ago, you told me not to multiply them out. That's why I sometimes hesitate when I answer your question, because there isn't always an absolute. All right, I need to simplify the numerator. If I need to simplify the numerator, do I need to multiply these things out?
Yes.
Yes. Do I need to multiply the denominator? No, because I'm not reducing that. Nothing will be combined. All right, so I need to distribute in the numerator and leave the denominator factored. So the bottom will be 2x, parentheses, x plus 5. I'm multiplying now. What is 2x times 6x? 12x squared. So everybody's putting a 12x squared down. Now, the minus sign always messes kids up. So I'm going to put the minus sign, then I'm going to put a bracket down just because I want to remind myself that I have to distribute the negative after I do this multiplication. I now have to multiply these two things together. It's been a while. So let's practice. If I'm going to multiply those two things together, I need to multiply x and x. What's x times x? X squared. Stay with me now. I do my smiley face. How much is this? Negative 2x. Then I do my other smiley face, which is plus 5x, and then minus 10. Everybody good with that? All right, now one more time. Take your time. 12x squared minus, then it would be x squared plus 3x minus 10 over 2x times x plus 5. Now I have to do what to the numerator? Distribute the negative. So this is going to be plus. This is going to be a minus. This is going to be a minus. And this is going to be a what? Plus. So what is 12x squared minus 1x squared? Come on, come on, come on, wake up. 11x squared. Then negative 3x positive 10 over 2x times x plus 5. Now, you're always technically supposed to look at this and say, does that factor? All right. And right now, it does not factor. So guess what? That's our answer. All right. That's our answer. All right. Let's do one more. Let's take a look at 19, guys. Last one. All right, now we have a problem here. The reason why we have a problem is because 2d plus 2 is not factored. So you have to factor that. What does that factor to?
2.
2,
D plus 1.
and then d plus 1. All right. And then this is just d plus 5. All right, so what is the common denominator this time?
2d plus 1 and then d plus 5.
That is exactly correct. Everybody take a look at that. All right, come on, write that down. That's the common denominator. All right, now I need everybody to look at the first fraction. What is missing in the first fraction? What? Is everybody okay saying that D plus 5 is missing in the first fraction? So that means I have to multiply the top by what? D plus 5. So I want everybody to put a 5 parentheses D plus 5 minus D, right? Minus D. Now, what's missing in the second fraction?
2D plus 2.
That's correct. Well, I'm better thinking 2 parentheses D plus 1, even though you're
Oh,
correct.
yeah, 'cause you- so-
Yeah, 2 parentheses D plus 1. So it's going to be 2 parentheses D plus 1. Everybody write that down. All right, now from there, I need to distribute the 5. When I distribute this 5 times D is what?
5D,
5 times this 5 is,
25.
so everybody's going to have 5D plus 25. Now, here's where you got to be careful. I try to explain to kids all the time. You're distributing a negative 2D. All right, I want everybody to make sure you're hearing me. You're distributing a negative 2D. So what's D times negative 2D? Negative 2D squared. And then negative 2D times positive 1. What is that? Negative 2D. All over, and then 2 parentheses D plus 1, D plus 5. Now it's just a matter of combining terms. Is there anything I can combine with the negative 2D squared? No. So everybody's going to put down negative 2D squared. All right, what combines now?
5D negative 2D,
Which is what?
3D.
Plus 3D. And then what? Plus 25.
25 now, pass through it.
And then all over that denominator. And once again, you're kind of supposed to look at this numerator and say, does that factor? Does that factor? No. All right, now, again, remember, I'm really not trying to stress you out. I'm trying to help you out as much as I possibly can, which means I'm trying to do the work. All right, I'm really trying to do the work for you. But if all you're doing is just writing down my notes, is that helpful? It's really not. All right, just copying things off a board does not mean you're learning anything. All right, now I am going to double check real quick to see what time the bell rings. So what time does it ring?
5:30.
It rings at 29, right? So we have like 4 minutes. So here's what I got. All right, let's go ahead up to the top. All right, everybody just look at the top real quick. I'll give you a break. I just want to see. All right, on the top. Is there a common denominator already? Yeah. So the denominator is just going to stay what? 2. All right, now how many x's are in the numerator now? 2x. And then plus what? Plus 2. Perfect. Now, is that the final answer? No, because they all can be reduced by a factor of what? 2. So if I divide the top by 2, it becomes x plus 1. Now, technically, it's x plus 1 over 1, but do I care about x plus 1 over 1? No. All right. Everybody's good with that? All right, now let's look at the next one. Come on, stop talking. All right, stay with me. I want to do some more problems. All right. You guys are not going to sit next to each other tomorrow if you keep talking. You all keep thinking I'm playing around. I'm trying to help people. All right, you keep interrupting. Don't sit next to each other. All right, here we go. This negative becomes a what? The 3 becomes the positive x becomes a negative x. Does it already have a common denominator? So that's 5x. What's 7 minus 3? Wait a minute, 7 minus 3. We're combining terms. 4. And then what kind of x? Negative x. Now, again, if you can't see it, tell me what? No, because we're not multiplying anymore. Because it already has a common denominator. You with me? We didn't have to multiply anything. We already had a common denominator, so you just have to combine the numerators. All right, that's it. All right, last one, I promise. All right, then we don't have any homework if you pay attention. All right, here we go. I need help. All right, the common denominator with 4 and 5 would be what? 20. Now, I ask you to take the largest amount. How many x's are we going to take? How many y's? That's it. That's all there is to it. The common denominator is 20xy. So now you look at the first fraction, you say, what's missing? A 5y. And I don't understand why people can't do this. So I multiply the first fraction by 5y. Now, come on. What do I multiply the second fraction by? 4x. That's it. I'll multiply the second fraction by 4x. So the first numerator is going to be what? 15y. The second numerator is going to be plus 8x. That's the answer. There's nothing to it. All right, nothing to it at all. So again, tomorrow we'll kind of take off. Listen, you're judging yourself now. Do you know how to do it? All right, we'll finish it up tomorrow. All right, but if you're struggling a little bit, look at the notes, review. All right, I'm not going to waste so much time tomorrow. I'm going to move faster. All right, and there's still a lot to do. All right. All right. Have a good day. That was actually pretty good.